A white light is incident on the interface of glass and air as shown in figure. If the green is just total internally reflected, that means green light experience TIR. Then the emergent ray in the air contains. Emergent ray in will contains. Emergent ray means what? Refracted ray. Emergent ray means refracted ray. The ray which will come here outside, this ray will contain which colors? They are asking. Right. So V I B G Y O R as we have discussed. So as we move this right side, what happened to wavelength? Increases. Wavelength increases. Refractive index is directly proportional to wavelength. Okay. So that means, so look at now here, they given the conditions. Yeah, refractive index directly proportional to wavelength. As wavelength is high, refractive index is also high. That is the other thing. Now, what else we can write? You tell me now here. So this is here. They mentioned that green get TIR. Green get TIR. So that means what is the, so this is the angle of incidence, right? I. Now, so that means in this case, what is the I now must be equal to green is get as a grazes the surface. So that means I must be equal to what we can say now, we can say that is sine inverse of what we can say mu r by mu d. Mu r means 1 and this is mu d means what we can say refractive index of a green. Okay. Refractive wavelength is high means refractive index is also high. Okay. So that means we can say this as sine I, which is equal to what you tell me now 1 by mu g. Okay. So this is the angle. So this is the angle of incidence. I is the angle of incidence for each case. Okay. Now tell me now here in this case, let's find the critical angle. Critical angle, if it is greater, then only can happens. Now you tell me now here, let's talk about the, let us say, whether it will be to the left side or right side, we need to see. Let us talk about the red if I talk now here. So what is the critical angle for the red, you tell me now? Critical angle for red, which is given as sine inverse of what, tell me now? 1 by mu red, I can say. Yeah, now we need to identify this thing here. Look at now here, this one, whether this is the angle of incidence greater than the critical angle or not, we need to see. Angle of incidence greater than the critical angle or not, we need to see. So you tell me now here, and in this mu g and mu r, which is greater value? Yeah, mu g and mu r, which is the greater value? Mu r is greater. Yes, mu r is greater than mu g, isn't it? And then if we have taken the 1 by we have taken now, then it is 1 by mu r is less than 1 by mu g, I can say now. Okay. Now you tell me now, I have taken the sine inverse on both sides. Sine inverse we have taken. So then it will becomes what, tell me, understood this point, what I'm doing now here. Refractive index of red is greater than refractive index of a green first. Now we wrote it as 1 by mu r, then it is less than 1 by mu g. Now we have taken sine inverse on both sides. Sine inverse of 1 by mu r is less than sine inverse of 1 by mu g. Now tell me, isn't it? This is nothing but what terminal critical angle for the red color, na? Critical angle of red. Critical angle of red, which is what you tell me now. This is nothing but what, tell me now here, 1 by this is the angle of incidence only. This is I. So this means I value greater than what, tell me now, theta c of red. Hana bol. So that means what, tell me now, what happened to red now here? Angle of incidence is greater than critical angle. That means red color will be refracted or TIR can happen. Yes, so TIR will happen now. So that means from this what we can say, obviously this right side, these three will experience a TIR and these three will get refracted. Now tell me now. Right. So from this, the emergent ray will contain which colors? Violet, indigo, blue. The emergent ray will contain which colors? Violet, indigo, and blue.